You know when you look at a block of code and it just seems, well, complicated? Ever wonder how all those symbols on a screen can actually become a real working application? Well, that's exactly what we're going to break down today. We're going to peel back the layers of a programming language and see how it all fits together in simple, understandable parts. And honestly, thinking of it like learning a new language, that is the perfect way to start. This one idea is the key to everything we're about to cover. Because just like any spoken language, programming languages have an alphabet, they have a vocabulary, and they have rules of grammar. Once you get that structure, writing code becomes so much clearer. All right, so here's our roadmap for this explainer. We're literally going to build a Python program from the ground up, starting with the absolute smallest pieces and working our way higher. We'll go from individual characters to words to sentences and finally to a complete story. Let's dive in at the very beginning. Okay, level 1, the character set. And you can think of this, quite literally, as the alphabet of the Python language. These are the only symbols that Python even recognizes as existing in its world. So this alphabet is basically made up of 4 main groups. You've got your usual suspects, right? Letters and digits, that makes sense. Then you have all those special symbols, which act like tools. And then there's this last one, and this is a big deal in Python, white spaces. In a lot of other languages, they don't really matter, but in Python, they are absolutely crucial for giving your code structure. And that's the bottom line, right? Without an alphabet, you can't even form words. Every single thing you will ever write in Python, it's all built from these basic characters. This is the bedrock, the foundation for everything else. So, we've got our letters. What's next? Well, we start putting them together to make words. And that brings us to level 2, tokens. If characters are the letters, then tokens are the actual vocabulary, the words in our new languages dictionary. First up in our dictionary, we've got something called keywords. Think of these as special VIP words that have a built-in meaning. For example, when Python sees the word if, it knows exactly what to do. A decision needs to be made. These words are reserved. They're off limits for you to use for anything else. Now, on the flip side of that, you have identifiers. If keywords are the words Python gives you, identifiers are the names that you get to make up. Whenever you need to store some information, you give it a name, like student_name. These are your custom additions to Python's dictionary. Then we have literals, and these are super simple. They're just the raw, fixed data in your program. The number 42 is always going to be 42, and the text, hello, is always just, well, hello. No tricks here, it is what it is. Next, we've got operators. These are the action words, the verbs of our language. That plus sign? It's not just a symbol, it's a command. Add these things together. Operators are what make our code actually do stuff. And last but not least, punctuators. You know how we use commas and periods and parentheses in English to organize our sentences? That's exactly what these do in Python. They don't really perform actions themselves, they just keep everything neat, tidy, and structured. So see how that works? We take our letters, the character set, and we build them into meaningful words and symbols, our tokens. And just like that, we have our entire vocabulary ready to go. Okay, so we have a dictionary full of words. What do you do with words? You put them together to make sentences, right? Well, in Python, we call those sentences statements. A statement is one complete instruction that tells the computer to perform a specific task. And this slide just nails it. Look on the left. You've got 3 separate tokens, the identifier X, the operator equals, and the literal 10. By themselves, they're just pieces. But when you string them together in the right order, boom, you get X equals 10. That's a full command, a complete thought that Python can actually understand and run. And just like in any language, there are lots of different kinds of sentences or statements. You've got your simple assignment statements like the one we just saw. You've got conditional statements with if and else that let your program make decisions. There are loops that repeat actions and functions that let you package up entire chunks of logic to use again later. And that's the perfect way to think about it. A statement isn't just a random jumble of tokens. It's a complete, actionable thought. It truly is the fundamental unit of work in any program. So we've covered our letters, our words, and our sentences. There's only one level left, putting it all together to write a complete story. And in our world, that story is a Python program. You know, a good program, just like a good story, has a clear structure. It's not just a messy list of statements. It usually starts with some comments explaining the purpose. Then it sets up its tools and its data. And finally, it has the main block of code, the execution block, where the core logic actually runs. And that's the final piece of the puzzle. A program is the culmination of all these lower levels. Every character matters, every token has a purpose, and every statement is a step in the plot, all working in harmony to achieve a final goal. So there you have it. Coding isn't magic. It's simply a logical system built on these 4 layers: character sets, tokens, statements, and programs. When you understand how the smallest pieces build up to the largest, you gain a true understanding of how programming actually works. We've just gone over the fundamental grammar of the Python language, the structure, the rules, the building blocks. They're no longer a mystery. So the only question left is, what are you going to build with it? What problem will you solve? What story will you write? Happy coding!